Hi everyone. In today's lesson from Unit 4.2, we'll be taking a look at arcs and arc measure. A central angle is an angle whose vertex is at the center of a circle. So angle B is a central angle. And notice that its sides are formed by two radii of the circle. There's a radius, there's a radius. A minor arc is an arc whose measure is less than 180 degrees and has endpoints on the circle. So in our picture up above, arc AC is a minor arc. So use those two endpoints for the name and then just draw a little arc above it. A major arc is an arc that measures more than 180 degrees and has endpoints on the circle as well. Now, 180 degrees will be a semicircle. We'll talk about that in a second. But if we wanted to name a major arc in this picture, one possibility for us would be to go from point F to point E to point D. So a major arc, use three letters to name it, and we can go F, E, D. Or to name that same arc, we could call it D, E, F. The order of the letters is important because it tells you which way to go around the circle. A semicircle is an arc with endpoints on the endpoints that are endpoints of a diameter. They're on the circle, and a semicircle measures exactly 180 degrees. So I could say the measure of arc GHJ is equal to 180 degrees. You see that GJ is a diameter because it goes right through that center, so this is a semicircle. From here to here, from G to J is also a semicircle. We don't have a way to name it unless we include another point and give it another letter. Then we could name that semicircle. So 3 letters for naming a major arc, 3 letters for naming a semicircle. Only 2 needed for a minor arc. Okay, the measure of a minor arc is equal to the measure of its central angle. So for instance, the measure of arc AB would be equal to the measure of this angle. So let's say that the central angle is 70 degrees, then the measure of arc AB would also be 70 degrees. So central angle, same as the measure of the arc. The measure of a major arc is equal to 360 degrees minus the minor arc. For example, the measure of major arc ACB, so trace that out with your pencil or with your finger, ACB goes all the way around, that would be equal to 360 degrees minus what we already know right here, minus 70. So the measure of arc ACB, that major big arc, is going to be 290 degrees. Sorry, my pen just went a little crazy there, so let's fix that, 290 degrees. All right, and then finally, again, the measure of a semicircle, 180 degrees. Okay, the arc addition postulate says the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So imagine, if you will, we have a circle, and we have this arc of, say, 50 degrees. We have this arc of, say, 60 degrees. The measure of the whole arc would be 110 degrees. Just add them together. Okay, congruent circles are 2 or more circles with the same radius. So if you see 2 circles and they both have a radius of 4, then they are said to be congruent to each other. Congruent arcs. Arcs are congruent if they have the same measure and they are arcs of the same circle or congruent circles. So you'd have to have, let's say we have 2 congruent circles, each with a radius of 4 inches. if we have a central angle of, say, 60 degrees, and this is arc AB, in this circle we also have a central angle of 60 degrees, and this is arc CD. Because both of those arcs have the same measure, 60 degrees, and they're part of congruent circles, then we can say for sure that arc AB is indeed congruent to arc CD. Okay, again, they have the same measure in degrees, and they're parts of congruent circles. Okay, last one. Just a couple quick questions for a CYU. It says, given that AC and BE are diameters of circle F, determine whether the arc is a minor arc, a major arc, or a semicircle, then find the measure of the arc. Okay, so if we take a look, since BE is a diameter, we know that it divides the circle into two congruent parts. So I'm going to take 180 degrees and subtract these two central angles of 70 and 45 so that I can find this arc right here. So 180 minus 70 minus 45 leaves us with 65 degrees. Now, I'm just going to go ahead and find all these things first, and then we'll answer the questions. So if the central angle here is 70 degrees, the measure of this arc would be 70, because minor arcs, it's the same as the central angle. This would be 65, this is 45. Okay, these two angles are vertical angles, so they're congruent to each other. So this is 70, and that means that this is going to be 110, because 180 minus 70 is 110. So this arc is 110, this arc is 70 degrees. All right, now let's see what we can do with the questions. First, we have to say if it's a minor arc, major arc, or semicircle. So arc BD in number 1, notice that its measure is 45 degrees. That's less than 180, so it is a minor arc. Number 2, we're looking at arc AEC. So going from A all around to E to C. Notice that A and C are the endpoints of a diameter. So this is a semicircle, and its measure is exactly 180 degrees. Okay, from A to E now, it goes from here to here. Its measure is 110 degrees. I know it's big, but it's still a minor arc because it's less than 180. All right, from D to C, that's this arc down below, it's a minor arc, and its measure is 65 degrees. All right, from B to C, we're using the angle addition postulate here. Add those two together, and they will add up to 110. Still a minor arc, less than 180. All right, from A to B to C, I know this diagram's getting crazy. I'm going to add a different color here. From A to B to C, notice that those endpoints are the endpoints of a diameter. So this is a semicircle. So ABC has a measure of 180 degrees, and again, it's a semicircle. Okay, 2 more. ACD. So start with A. We have to figure out which way to go in here. I'm going to erase some of this. I have a feeling that ACD is going to be a pretty big arc. In other words, a major arc. So let's follow it all around. We have to end up at D, so I want to go this way. Go A, all around to C, and to D. So that's everything in this circle except for this piece over here. All right? So you can either add the 110, the 70, and the 65 together, or you can take 360 and subtract 70 and 45. All right, so in the end, ACD should be 245 degrees, and it's definitely a major arc. Okay, for EAC, we're coming around the other way, E to A to C. I know it's crazy. And EAC is the whole circle except for this little arc of 70 degrees. So EAC has a measure of 290 degrees, and it is a major arc because it's greater than 180. All right, good luck on the homework.